Hey everyone, in this video, I'm going to start a new topic that is recursion. So basically in this video and in the upcoming videos, I will be discussing what is recursion and how we can think to make a recursive code for a given problem. Okay, so many of the people who are actually beginner, or let's say the people who have actually understood about the recursion, they also face the problem in writing the recursive code. Okay, so in this video, I will be telling you some of the basic things which are actually needed before understanding the recursion. And in the upcoming videos, I will be telling you that how we can think to write the code in the recursive manner. Okay. So we will take many problems which will help us to understand the recursion in a better way. And we will also take various examples to understand this recursion. Okay. So I hope by the end of this playlist, you will be able to understand the recursion in a very in-depth manner, and you will be able to write the recursive code in a confident way. So let's start. So basically in this video, I will be discussing some of the prerequisites for the recursion. Okay. And in the next video, I will be formally starting with the recursion. Okay. So let's start. So basically for understanding the recursion, we should have the knowledge or the understanding or the basic understanding of the functions. Okay. We should know what are functions and how they works. Okay. So you can come from any background of the programming language like C, C++, Java, Python. It doesn't matter. Just you should know that what is function. Okay, and how it actually works. Okay, how it returns the value. Okay, you should know local, global, and the static variables. Next thing is you should know that how the variables or the code, okay, it is stored inside your main memory. Okay, that is you should know the memory layout of your program. Where are your operands stored in the main memory? Okay, and the next thing that you should know is nested function calls. You should know that how the nested function call actually works. That is how they are stored on the stack inside the main memory. Okay. So basically, I will be telling you something about the static variable, then the memory layout of the program, and I will be telling you how the nested function call are stored on the stack. Okay. In this whole process, I will be telling you some of the terms like call stack, stack frame, and the activation record, which are needed to understand the recursion. So let's take the first step to start our journey to the recursion. The first concept that we should know is memory layout of a C and C++ program. So basically, I have taken this example to understand that how the operands and the instructions, they are stored inside the main memory. This is meant by the memory layout. Okay. And it doesn't matter. I have taken the C++ program. You can have the any other example also. It can be in Java, Python, or any of the other language. Okay. There is just small change with respect to memory layout. Okay. With respect to your other programming language, but mostly the concept will remain same because we are understanding the concept. Okay. We are not aligned with any particular programming language. Okay, so let's start. So basically in this example we have the main function and we have the variables like a and b. Okay, and these are the like input instruction. Okay, say in, then we are adding these numbers, then we are printing. Okay, and then we are returning. So basically in a program we have the instructions. Okay, and we have the data or the operands on which our instructions work. Basically these are the instructions like taking the input from the user, next is adding the numbers and then storing inside a third variable. Okay, then printing the result. Okay, and this a and b, these are like operands or the data on which our instruction will work. Okay, so when we are saying okay, take the data from the user, so it will be stored inside the a and b. When we are saying adding the data, that means a and b, they will be added by the instruction plus. Okay, so basically when this program is compiled by the compiler, then we get a executable file. Okay, so let's say our executable file name is sample.exe. Now this sample.exe, when we double click, it gets stored or loaded inside the main memory by the operating system, right? Let me make it large. So basically our sample.exe, or you can say executable, which are created after the compilation process of this program, it can be stored anywhere in any of the free space inside the main memory. So basically, let's say we have a program or application P1, it can be stored here. There can be other program that can be stored here. Okay, the same way sample.exe can be stored in any of the free space. The next thing that we have to understand is when this program, or you can say this application, gets loaded inside the main memory, then actually it gets divided into 4 parts. Okay, what do I mean is when this application is stored here, then actually there are 4 sections, okay, that are created for any of the application. Okay, and the instructions and the data, they are stored in these 4 sections. And how they are stored, let's see. So this is our main memory. Okay, so basically when this sample.exe, it gets loaded by the operating system inside the any of the free space in main memory. Okay, then these are the 4 sections: code sections, data section, heap section, and the stack section, in which this sample.exe will be, you can say, broken down. Okay, so basically this whole space is taken by your sample.exe. Okay, the same way, let's say there is another application P1, it will also be divided into these 4 parts. Okay, so basically this code section actually stores the instructions or the code part of our program. Okay, so these are the 3 instructions, right? So these instructions will be stored here, right? After compilation of this program, there can be more instructions generated, right? But let's say for the simplification, we have only these 3 instructions. Okay, so they will be stored here, right? And the CPU takes the instructions one by one from this code section and execute those instructions. Now, instruction actually works on the operand, as I told you, right? So the operand will be stored in these 3 parts. Okay, now depending on the nature of the operand, they can be stored inside the data section, heap section, or the stack section. In the data section part, the global and the static variables are stored, which are present inside your program. In the heap section, the memory which is taken at the dynamic time, that memory is taken from the heap. So basically, malloc, calloc functions, these help us to take the memory from the heap in dynamic time, or you can say at the runtime. So basically, let's say we have this instruction or this, you can say, function call by the malloc, okay, in our program malloc, and it is creating an array of size 4 at the runtime. Okay, so the memory will be created or be taken from the heap. 4 integer size space will be taken from the heap, and all the data will be stored in this array in the heap only. Now here you should know that this p variable, which is actually a, you can say, operand, this is not stored inside this heap. This is stored somewhere in the stack. Okay, I will tell you later. Okay, the last part is stack. In the stack, we store the function related information, or you can say various function call related information. Okay, and this is the part that we are going to discuss very soon in the video. So basically, stack and heap, they can grow. Okay, so if stack size become full, okay, then it can go down and it can take space from here. Same way, heap can go up and it can take space from here. Okay, so they are like flexible. So let's take the full example to understand how the various operands are stored inside this main memory. So we have this program. Okay, we have the global variable int y, we have the static variable x, and we have some local variable a, b, n, which are actually present inside this main function. Okay, and we are taking the data from the user, we are adding, then we are taking another data, that is n, from the user, we are creating an array of size n, okay, using malloc at the dynamic time, then we are printing this c variable, and then we are returning. Okay, so let's see where will different operands will be stored. So basically in the code section, as we know, the instructions, okay, instructions will be stored. Okay, so basically you can say the instruction that is reading the data from the user inside a and b, this will be stored. Okay, then add a and b and assign the result inside the c, this will be stored here. Okay, so same way other instructions will be stored, but a and b, they will not be as such stored inside this code section. Okay, here instruction will say, okay, add a and b, but where will be a and b stored? They can be stored somewhere in the stack, heap, and data section. Okay, so operand will be stored here. So let's see how. So let's start. So basically this is a global variable. So as I told you, global variables and the static variable, they are stored inside the data section. So y will be stored here. Okay, and what will be the initial value of the global variable? It will be 0, right? The static variable x, it will be again stored here. Okay, so x, again, initial value, as we know, for the static variable is 0, it will be stored here. Now we have the other operands like a, b, and n. Okay, so basically a, b, n, they are not static variable or the global variable, so they are not stored here in the data section, and you can say these are not related to dynamic memory allocation. Okay, so again they cannot be stored here, so the space that is left is stack. So basically local variables, okay, which are present inside the function, they are stored inside the stack actually. Okay, so I will tell you again in the more detailed manner in the upcoming part of this video. Okay, so basically a, b, and n, this will be stored here. Okay, and now we are taking the data from the user A, B. Okay, so basically CPU will fetch the instruction from here. Okay, and it will say, okay, we have this instruction, read the data from the user inside A and B. Okay, so CPU will say, okay, take the data from the user. So let's say A is 5, that is entered by user, and B is 7, entered by user. So basically inside the main memory, A equal to 5, okay, it will be stored here, and the value of B, 7, will be stored here. Okay, so instruction are fetched from here, data is stored here. The same way we will go forward, and then we will add A and B. Okay, now where will be your N stored? N is again here, right? So let's say N is, let's say 4, entered by the user. Now this line is saying create a memory, okay, of N size. Okay, so basically he will give us this memory. Okay, the space will be taken from here of 4 size. Okay, and the address of this space, okay, it is written in the P. Okay, so this P variable, as I told you, it will be stored here. Let's say the address of this main memory, okay, or you can say this space, is 200. First box is starting from the 200 index. Okay, or you can say memory location 200. So inside P, 200 will be kept. Okay, but P will be stored inside the stack. Okay, and now the same way we can go further, and here you can see we have the another variable C also. So C will also be stored here. Whatever the answer of A and B, okay, it is 12, it will be stored here. Okay, so basically inside the stack there are some other information also which are stored. Okay, so I hope you have understood this example. Let's now more focus on the stack part. Okay, so our next topic is nested function call and how they are stored on the stack. Okay, so basically in this example we will be focusing more on the stack part, that is how the various function call they are related to this part. Okay, and here you will be able to understand this stack in a more detailed manner, and this is very much needed for the understanding of recursion. Okay, so see very carefully. Basically, as you have done in your programming, that how the control will go. First we will come to the main. Okay, that is OS will call this main. Okay, and then this work will be done, and then f function will be called, control will come here. Okay, then these things will be done, and then control will go from this function call to the main function definition, right? After this is over, then what happens, then the control return back, okay, to this caller. Okay, f is the caller for g function, so again control will come back to the f function, right? And after that, this g function, okay, as it has actually done its work, so the control will come to return 0, that is f function will also return. But where f function will return, how it will get to know that where it has to go back? Actually it has to go back to the main function, right? So how this f function will be able to know that I have to return to main? The same problem can happen with g function also. After g function has done its work, then how g function will be able to know that I have to return to the f function, right? And inside f function I have to return to this line. How the various functions will be able to know that where should they return? And the other thing is, when main function is calling this f function, then f function is taking some parameters or the data, right? So where this data will be stored, okay, so that f function can later on work on this data. Same g function will be storing this data which is given by f function somewhere. Okay, so where this data or the parameter is stored, okay, so where these function call and the parameter will be stored, this is the main question. Okay, and how the return of the various function call will be known to the various, and how one function will be knowing that where it should return. The answer is stack. With the help of stack, we can actually give the answer of these all questions. Okay, so basically for this program or the application, this stack part will be used to store the function call and the parameter with other information. And what are those other information? Basically I can make it large. Okay, let's say this is the enlarged part of the stack. Okay, this is the part. Okay, so basically stack stores the function call information or the information which is related to function calls. Okay, and these various small parts, they are called the stack frames. Okay, or you can say the frames. Okay, so inside each of the frame, okay, there are various information stored related to your function calls. Okay, so basically each of the stack frame contains the local variable of a function, value of parameters which are actually passed to that function, okay, and the number of argument received. Okay, So basically, as you can see, inside main function, these are the local variables, right? Inside the f function, these are the local variable c, okay? And this will also be treated as the local variable for the f function. The same way, g have some local variable d, e, right? Okay. And as you know, here I have not written that you can say this stack will contain the static variable, okay? As we have discussed, static variable, they are not stored inside the stack, they are stored inside the data section. This we have to take care, okay? And the number of argument received, for example, f function has you can say received how many parameters, okay, or how many arguments from this main function? Only one, that is a, okay? So this count will also be stored in each of the stack, okay? Lastly, the return address, okay, it will also be stored, okay? So let's see with the help of example how all this and let's understand all with this example that how everything will be stored on the stack. So I enlarge this stack part, okay, for this application, and see what are the things that are going to be stored inside the stack and how. So basically, first OS will call this main function, right? So for this application, main function related information will be stored. So main function is stored, right? And the local variable of this main function are a with 5 and b is having garbage value. It will be stored, okay? So I'm not writing anything. Let's say this is a garbage value, okay? Now the function call for the f function will be made, right? So from here, what will happen? F function is called, okay? And f function is given value 5, okay? So f of 5 will be called, okay? So this is the next information for the f function call, right? And when we will come to the f function, there are local variable c, okay, which is having garbage value, okay? In this, a is also like a local variable now. So a is having what value? 5, right? Now this all thing will be done a equal to a plus 3, okay? So basically here this a will be incremented and a will be 5 plus 3, 8, okay? Now this is all the information of, you can say, f function. This is all the information of the main function. So basically here you should be knowing some of the terms like stack binding, stack unwinding, activation record, call stack, okay? So basically this whole stack for this application is also known as call stack. Why? Because this stack is keeping track of the various function call, okay? So main function call, okay, then main call f function. So this stack frame is actually keeping track of the next function call, okay? Similarly, when we will call the g function will be stored here, or you can say information of the g function will be stored here, okay? So this way this stack is keeping track of various function call. That's why this is known as call stack, or you can simply say it is a stack, okay, for this application. And what are activation record? So basically these all information of the various functions, okay, these constitute activation record. So basically activation record is a data structure which is actually created when a function or a procedure is invoked or called. So here you can see when the main function is called by the OS, then main related information is stored here. When main calls f function, then all the information of f function is stored here. So this is the another activation record. This is the activation record for the main function, okay? Now same way, after f function comes here, then function g will be called, okay, with the value c. So g function value will be stored here, okay, with the value of the c, okay? Let's say whatever value of the c is here, it will be stored. So we will come here, and the local variable inside g are d and e. Both are having garbage value, let's say, okay? And let's say c is also having some garbage value, right? So basically all this information is going to be stored for the g function. So this is the activation record which is created when g function was called, okay? So this is the activation record for the g function, right? Now what is the other information that will be stored in each of the stack frame? So basically it is the return address. So basically when this g function, okay, will be over with its work, it will return to the f function, right? So basically when this function call, they are actually stored on each of the stack frame, then at that time only return address will be saved inside the stack frame. So basically first time this main function was called, its local variable was stored, and here return address will also be stored. So basically, as you know, when main function complete its work, then it returns to the operating system. Its control goes back to the operating system, right? So return address will be saved, okay? Let's say return to OS, something like that will be stored. when f function, okay, f function will be done its work, then it will return to its caller, that is main function. So basically here RA, that is return address of the main function, will be saved. Let's say main is having some, let's say, address as mx, okay, so mx means return to the main function, okay, so this address will be stored. Same way for g function, what will be the return address, that where it should return or where it should go after it is over. So g function will be done and then it will go back again to the f function. So the, you can say, return address something like f of x, that is return to the f function, it will be stored, okay. So this way you can say return address will also be stored, okay. So we have understood what is call stack, what is activation record, what is stack binding and stack unbinding. So when we are calling, okay, main is calling f, f is calling g, so this process of calling each and every function and storing everything inside the stack, it is like stack binding, okay. This process is stack binding. And as you know, when this g function will be over, then what will happen, this all information, okay, it will be erased, okay. By saying that g function has to return to the f function, the control will come back to the activation record of the f function, and this all data will be erased from the stack, okay. Now when f function, okay, when f function will be done, okay, as control has come here, okay, from g, okay, then f function will be over. So f function will return to the mx, that is the main function, okay, and this all data of the f function will be erased. Now when we will come to the main function, that is from here we will come here, because this is the last part that where we have left, okay. Now a will be incremented to 9, okay, and then by doing its all work, main function will also return. So main function will also return to the operating system, okay, and then this all data will be erased. So in this way, when we are going up, stack was winding. Now stack is unwinding, okay, in the return journey, okay. So this process is known as stack unwinding, okay. In stack unwinding, all the activation record will be erased, okay. So basically, now we do not know the activation record, that's why they are erased. But in some of the languages, after the control of the, but in some of the languages, like after the control of the function is done, that is their work is done, then also their activation record may be needed, like in Java and in, you can say, in the Python, okay. There are some of the scenarios where their activation record may be needed when the function is also over, okay. So that time the memory layout may be somewhat different, but here we are not talking about some specific you can say languages. If we know this thing also, then it is okay, okay. Rest of the things may be dependent on the compiler, may be dependent on the languages, okay. Let's move forward. And before this, where this static variable will be stored of the g function, this will be stored inside the data section with initial value as 0, okay. So now let's move forward to the last topic. The last topic is static variable. This is the example to understand about the static variable. Here you can see we have two functions, main function, we have the f function, and inside main function we are calling the f function 3 times, f f f. Inside f function we have the static variable x, which is getting updated, okay, it is getting added by 3, and then we are printing this x, okay. So we have to tell the output of this program. So just to recall, what is static variable? Static variable are the variable which are actually associated with 4 things, okay. So basically static variable are stored inside the main memory in the data section part, as we have seen earlier, and the initial and the default value is 0. If we give, let's say, static int x equal to 5, then the initial value will be treated as 5, okay, otherwise it will be 0. And the scope of this static variable is local to the function in which it is displayed. That means where I can use this name x, can I use this name x in the main function also? That is, can I use this static variable here in the main function also? No. Okay. The area in which this x variable is recognized, it is only this f function, because inside f function it is declared. I cannot use this static variable inside the main function, okay. So this is the scope of this x variable. Now what is the life or the lifetime of static variable? So basically, when we come inside the f function for the first time, okay, then x is created inside the main memory, inside the data section. And after we are done with this f function, okay, and we go back to the main function, that is the caller, then this x is actually not deleted from the main memory. Its life is alive. That means x will remain still in the main memory, okay. It will only be deleted or destroyed from the main memory when my program will actually end, okay, not this function will end, okay. So let's find the answer of this. you can say code. So basically, when main function is called for the first time, its activation record will be stored here. Okay, and main function call this f function. Okay, so we will come here. So f function is created, or you can say the activation record is created for the f function. Now static int x. So this x will be stored with 0 value, right? 0 was the initial value because we have not given any other value. Okay, so this will be stored inside the data section. Now x will be updated by 3. Okay, so x is updated by 3 in the data section part. Okay, now we will print cout x. So here it is the output 3. Now when this f function is over, then its activation record will be deleted from here and only main will be left. So we go back again, okay, here, because this function is called done. Okay, so we are here. Now again f function is called. Okay, so we will come here. Now this static int x, this line will not be read again. Why? Because this x is still in the main memory. Okay, if we read this line static int x, that means we will create x again with the 0 value, but no, it will not be created again. Okay, so basically the control will start from x equal to x plus 3, the next line. So x will be, you can say, taken from main memory, that is 3, and 3 plus 3. Okay, it will be done with 6. So 6 will be updated inside x. So 6 is the new value. Okay, so basically the second function call, as we have called f, so its record was there. Okay, now cout x, that is this answer, that is 6. Now after we are done with this, we will again go back to the main function, that is the activation record now will be removed. Okay, now this third function call will again be made. Okay, and again the previous value of the x, it will be retained. Okay, previous value was 6. Okay, so again we will start from here. 6 plus 3, that is 9. 9 will be updated here. Okay, so we call the f function. Okay, now cout x, that is 9. Okay, and now again we are done, so we will come back again to the main function, that is only main is left, and after that there are no more lines or no more function call, so we will return. Okay, that means now main will also return to the operating system, so its record will also be deleted, right? So now nothing is left on the stack. So this way we got the answer 369. Okay, so this static variable is very much often needed in the recursion to solve our problems. Okay, so you should know that how the static variable actually works. Now if this static is not here, I hope you know the answer, that what will be the answer of the x variable, okay, by these three function calls. So basically if static is not there, then this is simply a local variable which will be destroyed after we go out of this f. Okay, so I hope you know that what will be the answer if we have only int x here. Then answer will be 333. Okay, so if you have any problem with this, that how the 333 will come, you can write down into the comment box and then I will answer them. Okay, I hope you know that how this 33 will come. Okay, if this static keyword is not here. Okay, so yeah, this was all about this video. In the next video we are going to start with the understanding of the recursion, that is what is recursion, and we will start with the basic problems, and then we'll move to the advanced problem, and then we will be able to know that how we should think to write the recursive code, what is the thinking pattern behind that recursive code writing. Okay, so if you like the video, please like, share and comment this video, and subscribe the channel and press the bell icon for further notification of the video. See you in the next video. Till then, goodbye.